Hi, my name is Cecil C. from SingaporeStudent.com. Today is 6th of May 2012. Today is a Sunday. The topic I would like to explain to you today is about limiting reagent calculation in mole calculation. I'm using a certain example to explain to you how to use a certain pattern to solve the question. Now, we are going to use the example of this question. I'm going to read it for you. 300 cm cube of sodium hydroxide solution with a concentration of 0.1 mole per dm cube is mixed with 200 cm cube H3PO4 solution with a concentration of 0.1 mole per dm cube. From this question, you can tell that this type of question is a limiting reagent calculation. Later, we are going to go deeper into that. We are going to know why. But for the time being, it's because if you see that the question gives information about two reactants, is usually a limiting reagent calculation. There are two questions from this information. The first question is find the concentration of sodium phosphate produced. The second one is ask you to find the concentration of H3PO4 after the reaction. If you read the second question, we already know that H3PO4 is going to be in excess. We are going to revise that later. Now, the question looks a bit complicated, but I find a way to explain to my students and they usually understand. The way I explain to my student is using this pattern, right? I standardize the blue box. These blue boxes, I have 3 of them for each substance. The blue box will be, the unit inside will be mole. So whatever information given in the question, we convert into mole first. So we are using this pattern in such a way that it is easy for you to calculate the answer. The first step is, of course, to balance equation. Sometimes the equation is given in the question. Sometimes the question don't give you. In that case, you must come up with the equation yourself. In this case, is easy because this is the reaction between acid and base. So let's say the question gives you this equation and you already balance sodium hydroxide and phosphoric acid. They will react to produce salt and water. And we see from the question, we check the information given from the question. 300 cm cube sodium hydroxide, concentration is 0.1 mole per dm cube. Information given in other units than mole, we are going to put it on this green box like this. Phosphoric acid is 200 cm cube. Concentration is 0.1 mole per dm cube. We are going to put that inside our information, inside this green box also. Now you have 4 information there, and we are going to put it here. 2 information is about sodium hydroxide, so we are going to fill in. For sodium hydroxide, the volume is 300 cm cube. And don't forget to convert it into dm cube. If you divide by 1000, of course, you're going to get 0.3 dm cube. And concentration is 0.1 mole per dm cube. The other two information is for phosphoric acid, so we put it on the second green box here, and it's not in moles, so we put in the volume, which is 200 cm cube. If you convert to dm cube, it will be 0.2 dm cube. The concentration is also 0.1 mole per dm cube. Now, we already put in the information. We are going to calculate the mole. For volume and concentration of solution, very simple. The formula is mole equals to volume times concentration, and is applicable only for aqueous solution, which is correct in this case. Sodium hydroxide is an aqueous solution. So 0.3 times 0.1, you get 0.03 mole. For phosphoric acid, the volume is 0.2 times 0.1, you get 0.02 mole. Now, a lot of students have a certain misconception. Usually the student thinks that if you have a higher number of mole for a certain substance, that substance will be in excess, which is not true. We are going, this is a very good example to explain that wrong concept, right? In this case, you're going to find out that phosphoric acid will be in excess. Why do I have 3 boxes here for each substance? The reason is very simple. The first box that you calculate from the green box here represents the number of mole that is available. So 0.03 mole of sodium hydroxide is available, and the one that is available in phosphoric acid is 0.02 mole. Now, some of these moles will react. Some will react, some will not react because it is in excess. Now, how do you know how much will react and how much is in excess? We don't know. We are going to do trial and error. So in this case, I'm going to give you an example of the wrong one first, right? I give you the wrong answer first, then later we can learn why that method is wrong. So we pick randomly. Let's say we pick we copy all this stuff, all the mole of H3PO4 that is available. We assume all of them will react. So 0.02 mole is available and all of them react. That means you have 0 mole in excess. What will happen if you do that? You have a mole ratio between H3PO4 and phosphoric acid. Remember, if you have empty space in front of the substance, it means 1. So we are going to use that ratio. So the coefficient of that substance becomes the ratio, and if you do that, you're going to have 0.06 mole. Now something is wrong here because you have only 0.03 mole of sodium hydroxide available. You cannot have 0.06 mole. If you calculate that way, that means the number that will be in excess is negative 0.03 mole, which is impossible, right? Which is impossible. You can't have negative number of substance in excess. So this is wrong. This is also wrong. Which means this is also wrong. So what is correct? The one that is correct is if we put the if we take the sodium hydroxide as the limiting reagent, that means we copy this number. We assume that all the sodium hydroxide will react. So if you do that, you're going to have (0.03 mole of sodium hydroxide that reacts, and you're going to have 0 mole in excess, which means there's no excess sodium hydroxide. The ratio must be 1:3. So you're going to have 0.01 mole, yeah. Then the mole of phosphoric acid that is in excess, we can easily calculate. So you have 0.02, 0.01 reacts. Of course, another 0.01 will be in excess. And we can easily calculate the mole of sodium phosphate, the one with the blue color here, in moles. So the ratio is 1:1. Remember, empty space means 1. So 0.01 mole here. So it's easy. So we find the mole. They are asking for the concentration. We need to use formula number 4 in mole calculation. Concentration equals to mole over volume. So we fill in here volume and concentration. The volume of sodium phosphate. Now the volume of sodium phosphate is not given. Remember, if your calculation involves aqueous solution, the volume after the reaction is you add up the volume of individual solution. So very easy. The volume will be 500 cm3, which is 0.5 dm3. So the concentration is 0.01 divided by 0.5. Very simple. We get 0.02 mole per dm3. Yes. So that is our answer for question number 1. For question number 2, they ask you to find the concentration of H3PO4 after the reaction. Also quite simple. We already find that we have 0.01 mole of phosphoric acid after the reaction. So we are going to use the same formula. The volume will be, because it's after the reaction, so you're going to add up 300 and 200 cm3. So the volume is 500 cm3, which is 0.5 mole per dm3. Concentration will be mole over volume. So see, we get 0.02 mole per dm3. So the answer for question 2 is 0.02 mole per dm cube. Let's revise what we learned today. First, we are using a certain pattern to solve for limiting reagent calculation. We are using blue boxes for mole and green boxes for other unit, volume, concentration, or mass. Then you have, when you calculate the mole of a certain substance, remember that you must ask yourself whether that mole, the number of mole that is that you calculate is the one that is available, or the one that reacts, or the one that is in excess. Another thing you must remember is you're going to follow the mole ratio from the equation, from balancing the equation. Another thing that students usually make mistake is, just now we found out that the higher number of moles, the substance with the higher number of moles might not be the one that is in excess. So we must do trial and error, right? And another thing, in the case of aqueous solution, the volume of solution after the reaction is, you add up the individual volume of each solution, right? When you mix the solution. So today we are learning about this mole calculation about limiting reagent. Hopefully this explanation is useful for you. You can check my website to download some of the files, some more exercise on this. And if you still have questions, you can call me at 962811754. Thank you again. Good luck. Thank you.